This is Activity 2, Thinking About Solutions from Lesson 7, All, Some, or No Solutions. And in this activity, you're supposed to compare or look at each of these equations and decide whether or not the equations are true for all values of the unknown of the variable or true for no values of the variable. So as we go through this, you're going to see what I'm doing. I'm going to treat each side of the expression as separate equations for lines. And let's see how that plays out. You're going to get two possibilities, but in all cases they're going to have the same slope. So let's see what happens here. So the first one's pretty easy. N equals n. Well, any value you choose for n is going to equal the same value on the other side. Now you can rewrite this, and I'm going to treat these variables as x because I want to look at them as y equals mx plus b, the y-intercept form or the slope-intercept form of an equation. So if I treat these as x and look at them as y equals x plus 0, and this is y equals x plus 0, then you see that y equals x. And that's an equation for a line that goes through 0 and it has a slope of 1. So we'll get more into that. It'll make more sense to you as we go through these. So the next one, 2t plus 6 equals 2 times t plus 3. And they're always going to have, all of these are going to have the same slope when you compare each side and you write equations for each side. So in this case, the slope is 2. So that's the coefficient of the variable. And do you see that the slope on this side is also going to be 2? And so what's the y-intercept going to be on this side? It's going to be the 6. What's going to be on this side? Well, 2 times 3 is 6. So these are going to be the same on both sides. So they're the same expressions, and if you write each one of them separately as equations for lines, they will be the same line. And so therefore they will be true for all values of t, or if we call t x, all values of x. So 2 times t plus 6 equals, if we use the distributive property here, 2 times t plus 2 times 3. So you have two groups of t plus 3. That means you have 2 t's. And you have two groups of 3. That means you have a total of 6 things. And so this expression is 2t plus 6 and 2t plus 6 on this side. So now you can write each of these as separate equations for lines. Y equals 2x plus 6. Y equals 2x plus 6. We'll get into the graphing a little bit later in this lesson. I'm not going to graph these now. The next one. So the slope is going to be 3. So it's 3n right here. So the coefficient of the variable, and if we call that x, it's y equals 3x plus 1. The slope is the coefficient of the variable, which is x, or n in this case. So the slope is 3, and in this case, do you see that the slope is also 3 on this side? So these lines are going to be parallel at minimum. Now they might be the same line, but at minimum they will be parallel. Now notice that this one is going to cross through the y-axis at 3. So it's 3 times 1 is 3. This one's going to intercept the y-axis as 1. So these are going to be parallel lines. They're never going to intersect. They're never going to share the same common point. So they will never have values that make each side of this true, make the whole equation true. So using the distributive property, this is 3n plus 3 times 1. 3n plus 1 on this side, and that 3 times 1 becomes 3. If you go one step further and subtract 3n from both sides, you get 3 does not equal 1. Okay, the next one. The next one, there are no values that make this equation true. So this is going to be each side of this equation, if you treat them as separate equations for lines, they're going to be parallel lines. And what's the slope? The slope is going to be 5, because that's the coefficient of the variable. Do you see that's the same slope here? 1/4 of 20 is 5, but this one is going to intersect the y-axis at 4. This one's going to intersect the y-axis at 0. This is a proportional relationship on this side. Y equals kx. Y equals 5 times x, or 5 times d. So if we work that out, 1/4 times 20 is 5, so 1/4 times 4 times 5, 1/4 of 4 is 1. This becomes 5d plus 1/4 times that 4. 1/4 of 4 is 1. So this becomes 1 right here. And you can write this as 0. So this is 5d plus 0. So it goes to the y-axis at y equals 0. This goes to the y-axis at y equals 1. So again, parallel lines, they're never going to share the same point. They're never going to have a common point on a coordinate grid, both of those lines. So they never intersect. Next one. So this one, the slope is 3x. Do you see that? It's 3x right here, 3x right here. And the y-intercept for this one is going to be -4. So this is -10 plus 6 is -4. And it's the same over here. 5 plus a -9 is also -4. So if we simplify the expression on this side, you get a -4 plus 3x. On this side, a -4 plus 3x. So if I write each one of these as separate equations for lines, this has a slope of 3. Slope of 3 crosses the y-axis at -4, crosses the y-axis at -4. They are the same line. So all values that you choose for x will always make this equation true. And the next one, this has a slope of 1. The coefficient of that x right there is 1, but they cross the y-axis at different points. This is 1/2, this is 1/3. So y equals x plus 1/2, so it crosses the y-axis at 1/2. Y equals x plus 1/3, crosses the y-axis at 1/3. They are parallel lines though. They both have a slope of 1, but they never are going to intersect because they are parallel. They're never going to share a common point between them. Now if I subtract x from each side or add a -x to each side, same thing, you're going to get 1/2 is not equal to 1/3. The next one, this one you have to multiply. So the coefficient of this y, or the coefficient of x here, y equals 18x. If you're going to write the equation on this side, you're going to get the same thing on this side, y equals 18x. Now don't get confused, I'm calling the equation y equals mx plus b, but they use the variable here as y. So this is a positive 18y, and this is a positive 18y. So if you look at it on this, simplifying this, this is pretty easy here. It's 2 times 9 is 18, so this is 18y. A little bit harder here because you have to think about the negatives. And one way to look at this is factoring out -1. So this is -1 times 6, or the opposite of a positive 6, and this is -1 times 3, or the opposite of positive 3. And then you can use the commutative property to move that 6 next to the 3 out here. This is 18. And move the -1s next to each other. So the opposite of a -1 is a positive 1. That's one way to look at that, one of many ways to think about that. So a negative times a negative is positive because you can factor out the -1s, and the opposite of a -1 is a positive 1. So you end up with 1 times 18, or 18y. So this is, again, a proportional relationship. The y-intercept is 0. So y equals 18x, has a slope of 18. So for one unit along the x-axis, you can go up 18 units along the y-axis. So y is going to be 18 times the length along the x-axis. And the last one, the slope again is 1. It's 1v, and it's 1v, but this is plus 2, and this is plus a -2. So if you add the additive inverse, so add a -2, so the y-intercept is -2 on this side, and the y-intercept is a positive 2 on this side. So v in this case plus a -2. So if you treat this as x plus -2 and x plus positive 2, slope is 1 on both sides. So they are parallel lines. They're never going to intersect. So they're never going to share a common point. So there are 0 values of v, or if you want to call it x, that will make this equation true. So we're going to go through the graphing and later activities in this lesson. This is just an introduction. Hopefully you're getting used to the language.